This is chapter 12, section 12.6. I am going to discuss random variable and probability distribution of a random variable. First, what is a random variable? A random variable takes numerical values that describe the outcomes of some chance process. Then what is the distribution of a random variable? The probability distribution of a random variable gives its possible values and their probabilities. Let me explain this using example 13. Consider tossing a pair coin 3 times. You already know how to write the sample space. Let me write down the sample points. HHH, HHT, HTH, HTT, THH, THT, TTH, TTT. How many sample points for this sample space? 8 sample points. Define a random variable. Here again go back to a random variable definitions. Takes numerical values that describe the outcomes of some chance process. Here I define x, the number of heads obtained. That is a random variable here. Then what are the x values? Before we count the x values, check the sample space. How many heads here? 3. Here 2. 2 is 1. Here 2 heads. Just 1 here, and here 0 heads. Only tail there, right? Therefore, possible x values are 0, 1, 2 and 3. Now write these numbers. X equals 0. X equals 0 mean no heads, right? Then this is just 1, TTT. Therefore, that is just 1 out of 8. Therefore, probability of x equals 0 is 1/8. Similarly, x equal 1, that means 1 head. So we use HTT, THH, TTH. Then how many we have? 3 out of 8. Therefore 3 over 8. Then x equal 2. Similarly we can write 3 elements. Therefore 3 over 8. The last one, x equal 3. That means 3 heads. We have only one element. That is probability of that is 1 over 8. So this table represents the probability of the distribution of x. X is the random variable. Here again understand the probability distribution of a random variable gives its possible values and their probabilities. Here you see possible values are 0, 1, 2, 3 and corresponding probabilities are here. So this is the distribution of x. Now discrete random variable. In the last video we discussed two probability models, discrete and continuous. Here also we are going to discuss discrete and continuous random variables. So you have idea what's the meaning of discrete and continuous. So what is the discrete random variable? How do we show the distribution of the discrete random variable? A discrete random variable x takes a fixed set of possible values with gaps between. The probability distribution of a discrete random variable x lists the values xi and their probabilities, just like I explained the previous example. We write the value of x and corresponding probabilities. Every probability pi is the number between 0 and 1. We know that already. Probability always between 0 and 1. Minimum is 0 and maximum is 1. The sum of the probability is 1. We saw this one, the previous example in the last video. The summation of the probabilities should be 1. To find the probability of any event, add the probabilities pi of the particular values xi. We worked on this type of example before, but I am going to explain again. Now let me go to the continuous random variable. What is the continuous random variable? A continuous random variable x takes on all values in an interval of numbers. As I explained in the previous video, if I consider numbers 1, 2, 3, 4, this is discrete. If I consider interval 1 to 4, then we have to consider each number between 1 and 4. How many numbers? There are infinitely many numbers. As an example, in between 1 and 4, we can have 1.001, 2.00009, right? Infinitely many numbers. The probability distribution of x is described by a density curve. Yes, we also know that part as well. The density curve, when we have a density curve, how do we find the probability? It is the area under the curve and between two numbers. The probability of any event is the area under the density curve and above the values of x that make up the event. Then go to the note. The probability model of a discrete random variable x assigns a probability between 0 and 1 to each possible value of x. A continuous random variable y has infinitely many possible values. All continuous probability models assign probability 0 to every individual outcome. Only intervals of values have positive probability. Now let me explain some examples. Example 14. Choose a parent with children under age 18 in the United States at random and ask how many nights a week out of 7 does your family eat dinner together at home? Call the response x. Here what is the random variable? Random variable is x. How do we define it? Number of nights, right? Number of nights your family eat dinner together at home. Then is it discrete or continuous? Yes, if I ask this question from you, what should be your answer? Maybe 1, maybe 0, maybe 6, 7, but nobody answer like 2.29 days or nobody answer like 4.7 days. That means we don't use decimal to answer this question. Therefore, x values are 0 to 7. That is discrete. Therefore, this is discrete random variable. Then you see probabilities 0.05, 0.00. We have probabilities for each corresponding points or each corresponding numbers. The first one is this valid finite probability model. How do we find if this is valid finite probability model? As I explained before, we need to get the summation of this probability. If the summation is 1, we can say this is valid probability model. If it is not 1, then this is not the valid probability models. Yes, you add them together, then answer is 1. Therefore, this is valid finite probability model. The second one, describe the event x less than 3. How do we describe this event? We can say eat dinner together at home less than 3 days. Right. Then x greater than 3. How do we define this one? We can say eat dinner together at home more than 3 days. The last part, x less than equal 3. So how do we define this event? We can say eat dinner together at home at most 3 days. At most 3 days. Right. Third one, find the probabilities x less than 3. We know this is discrete probability model. Therefore, probability of x less than 3 equal probability of x less than or equal to. This is true only for discrete model. Or x is the discrete random variable. Therefore, what are the values of this? You know x less than or equal to. Based on these values, we use 0, 1, 2. Therefore, probability x equals 0 plus probability x equal 1 plus probability x equal 2. Again, how do we find the probability of an event? We add all probabilities corresponding to x values of that event. So probability x equals 0, that is 0 0.05. Next one is 0.00. The probability x equal to is 0.07, that is 0.12. Probability x greater than 3. How do we find the probability x greater than 3? First, understand the numbers. What are the numbers we use this? We can write x greater than 3. This is x greater than or equal 4. Again, this is true for only discrete case. So, what are the numbers then? Probability x equal 4 plus probability x equal 5, probability x equal 6, and last one probability x equal 7. Then we can add x equal 4.1, next one 0.17, next one 0.15, and the last one 0.38. So this is zero point 0.8. That is the probability x greater than or equal 4. Last one, probability x less than or equal 3. Then how do we find this? Probability x less than or equal 3, probability x0 equal 0 plus probability x equal 1 plus probability x equal 2 plus probability x equal 3. So you can add the probabilities. But there is an easy way to find this. Let me explain that method. How do we write this using complement axioms? This can be written 1 minus probability x greater than 3. Okay, you see that x less than or equal 3. Therefore, we write here only greater than 3. So, this is the same 1 minus probability x greater than equal 4. Actually, we know this probability from the above part we discussed. So, we can write 1 minus probability of x greater than or equal 4 is 0.8. Then this is 0.2. That is the probability x less than or equal 3. The last one, 4. Express the event eat dinner together at home at least once a week. At least once a week x greater than equal 1. So, how do we find the probability of this x greater than equal 1? We can add all the probabilities corresponding to x values. X equal 1, then probability x equal 2, so on. So last one, probability x equals 7. We can use the axiom for complement event to solve this one. How do we do that? Probability x greater than equal 1, we can write 1 minus probability x less than 1. Again, here greater than or equal, therefore we write only strictly part, right? Then this is 1 minus, what are the numbers x less than 1? We have only x equals 0. Then 1 minus probability x equals 0 is 0.05. Answer is 0.95. That is the probability x greater than or equal 1.